Okay, so continuing on, let's go and see how we could actually find the way to get 5 trials and 3 successes. So we would use NCR on a calculator. Again, the screenshots were up at the end of that video we just finished, part 1. And you can, again, just type in the number of trials 5, then you'd use the NCR key under the math menu on your TI, and then you type in 3 for the number of successes. And it would tell you the number of ways to actually have that occur. So we would use NCR, and we can also find 12 successes from 48 trials. Go ahead and have a look at this number here and survey this on your own. You can pause the video and complete that activity. Okay, so let's have a look at finding the likelihood of success. So we can use NCR to find out the number of ways that something will occur, but we want to go further than that. We want to actually work out the probability of a certain number of outcomes occurring. And that's where we have this formula. We use that CNR, but then we have a look at the probability and the number of successes we want. So it's the probability of success raised number of successes we want, and Q just represents failure, where we have N being the total number of trials, and we subtract the number of successes. So as I said before, I've gone through P and Q. P is success, Q is failure. So from this we can conclude that P plus Q is going to be equal to 1, because the sum of all probabilities equals 1, and from that we can also conclude that N will be the number of trials and R will be the number of successes. So let's have a look at this question. The probability that a randomly selected student is studying physics is 0.79. Determine, if 5 people were randomly selected, what the likelihood of exactly 3 of them doing physics is to be. So again, P success is the fact that the student does do physics. That should say does do physics, sorry. So that's 0.79, don't let that confuse you. And the Q, which is a failure, is that they do not study physics, which would be 1 take 0.79. Note that, again, we can get that Q value because the sum of probabilities is 1. Sorry about that typo. And also note that N is the number of trials, in this case 5, because that's the number of students selected. So R is the number of successes needed, which we know in the question is 3, because we want to know the probability that exactly 3 of those 5 students are studying physics. So our equation looks like this. Again, we have the equation I just talked through, but we have C5 3. Again, we can work down a calculator, 5 NCR 3. And we should get a value, and then we multiply it by the probability of success raised to the power of the number of successes we need, and then we would have the probability of failure raised to, and again we take number of trials and we just subtract number of successes, so in this case it would be 2, because 5 take 3 equals 2. So use technology, we find that 5 NCR3 is going to be equal to 10, so it means that there are 10 possible outcomes to get exactly 3 people studying physics out of a group of randomly selected 5. And now we have 10, lots of 0.79 raised to the power of 3, and then we have 1 take 0.79 raised to the power of 2, and we get this probability here, which when rounded is 0.217. So the probability of selecting exactly 3 physics students from 5 randomly selected students is that probability there. And note that this is the probability of getting exactly 3, not getting at least 3 or more than 3, and that's why probability is quite low, because you could pick out 4 or you could pick out 2 or anything like that, but we want exactly 3, the occurrence where we only get 3, and what the probability of that is. So let's have another go, your turn. So I'll read out the question, then feel free to pause the video and give it a shot. Lucy is late for school once every 3 weeks. So determine the probability that out of 6 randomly selected days, Lucy is late for school exactly once. Remember that there are 5 school days in a week. So again, use this formula, that's your hint. And again, I've got the hint value there for n, the number of trials, and r, which is the number of successes we want. So pause the video and have a go. Okay, hopefully you've had a go now, so let's move on to the next slide. The answer, in this case, we would consider being late for school as a success. That does sound counterintuitive, but in this case, that's the outcome we want. Hence, the probability of success is 1 divided by 15, which is 0.067. And then we plug that value in. Again, we raise it to the power of r, the number of successes we want. And then we have n take r, which should be 5, because 6 take 1 is 5. And we'd use our calculator to find 6 NCR1. And we would actually find out that that would be 6 in this case. And then we would actually have 0.067 raised to the power of 1, so it would just be itself, multiplied by that probability, which is the probability of failure. And then we know that the probability that Lucy will be late to school exactly once is 0.284. So, there's a reasonable probability there. So again, there's an even quicker way to calculate these sort of questions using technology. So let's go through another question. Bill purchases a newspaper 4 times a week. If we were to check and see whether Bill bought a newspaper on 12 randomly selected days, determine the likelihood that he has purchased exactly 5 newspapers. That should be purchased. Anyway, probability of success is P, and that's going to be 4 divided by 7. So in this case, it's going to be 0.571. So go on our TID4, we'd go to second function, the button up the top, and then we press distribute, and then we go binomial PDF. We go PDF because we're just looking at the value of 5. CDF, which I'll get to in a minute, talks about cumulative probabilities. So a number of trials, because it will ask for trials. It depends on whether you have the new or old ROM, but you type in trial source, which would be 12, then the probability 0.571, and then you type in the X value of 5, and hence the probability that Bill purchases exactly 5 newspapers is 0.129. So what about ranges these values? Well, let's have a look at this. So the weather report claims that 2 times out of 5 it will rain on a Tuesday afternoon winter. So what is the likelihood that on 3 randomly selected Tuesday afternoons it rains 2 times or less? So again, 2 out of 5 equals 0.40, and the chance of rain, which for this question we would consider a success. We go on our TID4, second function distribute, and we go to binomial CDF this time. So trials equals 3, the probability equals 0.4, and the X value equals 2, because again we enter the value where we're looking at 2 or less. So 2 would be the maximum, so we plug that in, and hence the probability that it will rain on 2 or less Tuesdays, so it's looking at 2 or less, is 0.936, which as you know is quite high. So from the last question, determine the probability that it will rain on all 3 of the Tuesday afternoons. Again, the sum of the probabilities is 1, so 1 takes 0.963 equals P, hence P equals 0.064, and this is the probability that will rain on all 3 Tuesday afternoons, because the other question catered for it just raining on 2 or less. So what is the likelihood that it will not rain on 2 or less afternoons? Again, we'd take the probability of it not raining. We would actually go and say, okay, that should be a 2 there, sorry. But we go to binomial CDF and we go 3, and then we go 0.60, and then we type in 2. That's meant to be 2, and it would be 0.784. So a fair coin is tossed 25 times. What is the likelihood that it will land on tails no more than 12 times? So just have a go at that question. Again, think about, is the value the same for landing on heads as well? So pause the video, give it a go, and I'll reveal the answer. Okay, so the answer, again, binomial CDF, 25. We type in the probability. It's a fair coin, so it's 0.5 is the probability. And we want 12 successes, so it's approximately half. It should work out to be 49.999. And yes, it will be the same, because again, the probability is the same, and we want exactly the same number, so it will be the same result. So what about questions that ask at least? So let's have a look at these sorts of questions. 7 out of 10 students study for 3 hours per night. Determine out of a group of 12 students the probability of at least 8 students studying for this duration. So again, we got the probability of being 0.7 there, and we have the n value, the actual number of trials we have as being 12, and number of successes we need is at least 8, so it would be 8 plus. At least 8 means 8, 9, 10, 11, 12. So what we do is we use binomial CDF, but it looks at inclusive and less than. So what we do is we know that the sum of probabilities equals 1, so we do binomial CDF for 7 or less. Again, we assume that it is the probability that they are actually working for this long, and because of that we can take the probability and we can subtract 0.276, which is the probability we got from 1, and we get the probability that 8 or more students study for 3 hours each night, and that probability is 0.724. Yep, and let's have a go at another question. In a supermarket, for every 300 mangoes bought from local farms, 10 are rejected. So determine the probability that out of 1,000 mangoes, at least 45 are rejected. I'll let you do this one, and then we'll go through the answer in a moment, so pause the video and give it a shot. Okay, thanks for coming back, and the answer is, again, binomial CDF, but we use 44 as our probability, because again, that's what we need to enter. So it's binomial CDF 1,000, and then it's 10 over 300, 44, and it equals 0.971. And again, we subtract 1 from 0.971 to get the likelihood of 45 or more, and equals 0.029. So hence the likelihood of 45 more mangoes being rejected is 0.029. So very unlikely. Lastly, we can do spike graphs, which are visual representations of binomial distributions. You can plot them on your calculator. So first off, grab out your TI-84 and click on the Stat button and go into Edit. And let's evaluate bin of 10 and 0.60. So this first value here will actually be the number of trials per se, and this one here will be the probability of success. So L1 should have the numbers 0 through to 10. It shouldn't be 0 greater than 10, that's just a notation I use. 0 through to 10, you can see I've entered them in L1, do the same. And then for L2 you go up to the top of the column, make sure you clear the row, then press second function plus distribute, and then binomial PDF. Again, it's PDF because we don't want it to be accumulative, we want the exact value for each one. And now we fill in binomial PDF as being the number of trials, then the success rate, and then we press the L1 button. So we press the green alpha key, then we press the 1 button, and we get the L1 key. And so for each x value, we get the number of successes. So that's 0 success, 1 success, 2 success, etc., and the likelihood of getting exact that number of successes. So if we have 6 successes is our number of successes we need, and the probability is 0.251 when we round it. So now you need to turn on your scatter plot. So you go and you press second function and the y equals button on your TI-84. It's again near the top. And you select plot 1. Make sure you turn it on so you can scroll down using the arrow keys and press enter on the on button. And then you want to press graph. You may need to reset your window. You should be able to do that. Just press the window key up the top and then you type in the xmin, xmax, ymin, and ymax. I've got a suggested one there. Feel free to pause the video and do these instructions. So now let's have a look at some of the last final questions. What number of successes has the greatest probability? So just think about that with the last question that we did for bin 10 0.60. Hopefully you've done it on a calculator. And again, attempt to solve one of these values. Maybe it's a value of 6 or something like that, or the value of 7, whatever, for the last bin we did, and actually attempt to solve it again using the formula there with NCR. Again, you know how to do that on your calculator from the first part of this video. series, and then look at plugging in the alpha values and see whether you get the same result. So with sketch 1006, try to sketch 1004 on the same set of axes, and have a little think about what you notice. I won't go through what that means in this video, but have a think about it in context. And then also think about sketching bin 1005 as well. So this has been a quick PowerPoint series, 2 videos that discuss the basics of binomial distributions. There'll be more to learn and follow up PowerPoints and documents, but thank you, that's all for now, and that covers binomial distributions. Regards, and thank you very much.